Hello everyone. In the last session we have discussed about the basic concept of parallel AC circuit and we have understood how to calculate I1, I2, then power factor etc. Based on the concept, today we are going to discuss one important numerical example which can be expected for university examination. I request everyone to read out the question first. So let's read out the question. Two impedances of ZL is equal to 10 plus J15 ohm and ZC is equal to 6 minus 8J ohm are connected in parallel. If the supply current is 20 amps and what is the power dissipated in each branch? First of all, they have mentioned the value of impedance like ZL and ZC, both are connected in shunt or parallel fashion. The total current is 20 amps. Then what could be the values of power dissipated in each branch? How to solve this? First of all, it is better to draw one circuit diagram. So like this, and R and L you can draw, R and C also you can draw, RL series network, RC series network. Both are connected in parallel, correct no? RL which is connected parallel with the RC, correct? Now please see the values of ZL. ZL means 10 plus J15, Z is equal to 6 minus 8J. Please do mark like this. So R is equal to 10 and XL is equal to J15. Similarly, R value is equal to 6 ohm and X is equal to minus 8J. Correct? Total current is 20 amps and V they haven't mentioned. First of all, what you are supposed to do is, by using current division formula, you have to compute I1 and I2 respectively. So first let us compute I1. How to calculate I1? Can you apply current division rule? Total current is given, resistance of opposite branch is also given. Then you can able to calculate the total resistance. Please do apply current division rule. How to apply? So I am going to write current division rule. I into ZC. Okay, that means opposite branch divided by total impedance, that is equal to ZC plus ZL. So I means 20 amps and ZC is equal to 6 minus 8J. And ZC and ZL you have to add combinedly, collectively you have to add. Again you have to simplify. So denominator can be simplified first. Denominator means 10, these are the real part, add real part, 10 plus 6 means 16 and J15 minus 8J means 7J. And the numerator you keep as it is. Now what you can do is, please to convert into polar form. So here we can say that 20 is in a, what I can say, polar form. That means 20 means 20 angle 0 degree, 6 minus 8J and 16 plus 7J are in rectangular form. I think it is better to convert into polar form. So please to convert into polar form. 20 angle 0 degree. 20 can be written as 20 angle 0 degree. So here 6 minus 8J you have to convert into polar form, R angle theta form. So you have to use either calculator or manual method. Please refer my previous video. If you are using calculator, what to do? First of all, turn on the calculator, then shift, then you are supposed to use REC. Okay, sorry, you are supposed to use pole, POL, pole 6 minus 6 comma 8J. I will be writing here. So you have to use the shift, okay, shift, okay. Next, what you are supposed to do is pole 6 comma minus 8. If you do like this, no, you are able to get the value. So the value will be how much? 10 angle minus 53.13 degree. Denominator you can see 16 plus 7J. How to convert? Same manner, shift plus pole 16 comma 7. Otherwise you have to use the manual method. How to use the manual method? First of all, you have to calculate the magnitude. R is equal to square root of A square plus B square. Theta is equal to tan inverse of B by A. Anything is fine. Please refer my previous video. I have explained very clearly. So you have to convert into polar. Now what you can do? Look at the numerator. So this can be multiplied. Magnitude can be directly multiplied. 20 into 10 means 200. So 0 degree and minus 53.13 can be added directly. That will be minus 53.13. Denominator you keep as it is, like this. Now what you can do? Numerator and denominator you can do the simplification. How to do the simplification? Very simple. Yeah. What you can do is, this you can write direct division. Perform the direct division. 200 by 17.46. And angle part, what you can do, minus 53.13 minus 23.63. Division part you have to look at it. So you will be able to get in this fashion. So I1 is equal to 11.454 angle minus 76.76. So it is better to convert into rectangular form. You can convert into rectangular form. Everything is fine, but better write polar and rectangular form separately. I think it is right. Yeah. Now how to calculate I2? Again, current division rule can be applied. So other than that, I will tell you one idea. So apply KCL. According to KCL, 20 ampere is the total current. 20 is equal to I1 plus I2. Anyway, I know already the value of I1, just computed. So I2 can be computed, no? So by the way, I am following the same manner. So applying KCL, I is equal to I1 plus I2. Therefore, I2 is equal to I minus I1. So I2 will be 20 minus 2.623 minus J11.15. Now what you can do is, you can do the simplification. Okay, 20 means 20 plus 0 J, right? Okay, so this you can write as it is. Whenever you are removing the bracket, it will be positive. Please be careful while simplifying. So I2 you will be getting rectangular form as 17.377 plus J11.15. So please to convert rectangular form into polar form. It becomes how much? 20.64 angle 32.13. So by the way, we have got the value of I1 and I2 in this fashion. I1 is equal to 2.623 minus J11.15 amps, and I2, or else you can write in polar form, 11.454 angle minus 76.76. Please do verify. And I2 is equal to 17.377 plus J11.15. It can be converted into polar as well, 20.64 angle 32.13. So this is actually the thing which you are supposed to do. Now you have to calculate power dissipated at each branch. So first branch you can able to see, which is the first branch. It is an RL branch. No, see, 10 plus J15. Okay, so I1 is already computed. In that, don't consider the inductive part, because it never consume any power, right? It never be absorbed or dissipated. It never consume any amount of power. Which is the component that consumes power? Obviously this component, resistive component, that consumes power. Whenever you are calculating the power consumption, don't consider the inductive element. Okay, don't consider the inductive element. We already proved that the average power consumed by the inductive circuit is 0. So here you consider only the resistive part, and I hope you are understanding. Okay, so by the way, let us solve. I1 and I2 we have written separately. So power dissipated at RL branch is equal to I1 square into RL. Please do consider only the resistive part. I1 is already available, no? 11.454. See, 11.454. That means R part, R angle theta, no? Here only magnitude part is required. 11.454. See, 11.454 whole square into R. I square R you already studied, right? So this becomes 1311.94 watts. By looking at the RC branch, where is the RC branch? Yeah, please refer this. This is your RC branch. Here you have to consider only the resistive part. Don't consider the capacitive part. Yes. So by the way, you have to apply the formula. RC part means, see, I2 square into RC. So I2, what is the value of I2? We already computed, no? 20.64 angle 32.13. Here you consider only the magnitude, 20.64. See, 20.64 the whole square into RC. RC means 6. You will be getting 2556 watts. So this is actually the right answer. So in this session, what we have done is, they have given one numerical example. So we have gone through the problem of the parallel circuit with the help of that numerical example. So we have gone through the numerical example first. We understood that the values of RL and RC in this manner, and we have drawn the circuit diagram. From this circuit diagram, I have applied the current division formula. I computed the value of I1 and I2 by using the current division formula. Here I applied current division formula only for I1. For the easiness, I applied KCL. So I is equal to I1 plus I2. Therefore, I2 is equal to I minus I1. Then you convert into both the rectangular and polar form. That conversion you have to study. Don't get confused. Please refer my previous video. Afterwards, what I did is, I consider only the resistive element for the power dissipation. So by the way, there are two branches now. So the first branches means I1 into I1 square into R, I square into R. second branch the total power consumed is I2 square into R, correct? All right. So from